In previous lecture of NSAIDs, we have seen the introduction and general process of inflammation. Today we will continue the lecture with the classification, mechanism of action, uses and adverse effects of NSAIDs. But before starting that, we will quickly revise the previous lecture in which we have seen that NSAIDs have three major actions. First one is anti-inflammatory, second is analgesic and third is antipyretic. And then we have seen the general process of inflammation, in which we have seen that prostaglandins are the main responsible components for the inflammation, and they are produced from arachidonic acid, and this synthesis is catalyzed by the enzyme cyclooxygenase, of which short form is COX. The enzyme COX have two isoforms. First is COX-1 and the second one is COX-2. COX-1 is present in all normal cells, and COX-2 is induced when the injury has occurred. COX-2 is induced at the site of inflammation, which means the enzyme COX-1 is responsible for the normal physiological functions, and COX-2 enzyme produces prostaglandins which are involved in the process of inflammation. And based on the isoforms of this enzyme COX cyclooxygenase, the drugs NSAIDs are classified in main four classes. First class is non-selective COX inhibitors, then preferential COX-2 inhibitor, then selective COX-2 inhibitor, and fourth analgesic and antipyretic with poor anti-inflammatory action. Non-selective COX inhibitors inhibits both the enzymes of COX-1 and COX-2. Preferential COX-2 inhibitors inhibits both the forms of enzyme COX-1 and COX-2, but they prefer the isoform COX-2 over COX-1. Then selective COX-2 inhibitors only inhibits COX-2 isoform, and last class have more analgesic and antipyretic action and less anti-inflammatory action. Let's see the examples. First class is non-selective COX inhibitors, and in that there are 8 subclasses. First is salicylic acid derivatives, then pyrazolone derivatives, indole acetic acid derivatives, propionic acid derivatives, phenamates or anthranilic acid derivatives, aryl acetic acid derivatives, oxygen derivatives, and pyrrolopyrrole derivatives. You have to remember just these 8 subclasses, and from these subclasses you will easily can remember the examples of the drug. First is salicylate. So in salicylate, acetyl salicylic acid, which means aspirin, and second example is sodium salicylate. Second class is pyrazolone derivatives, and in that class the suffix in the drug example will be butazone, phenylbutazone and oxyphenylbutazone. Then in indole acetic acid derivatives, the word will be indomethacin and sulindac, indo and indac, indomethacin and sulindac, because they are indole acetic acid derivatives. Next class is propionic acid derivatives, in that ibuprofen and naproxen. Propionic acid derivatives, that's why profen and proxen, ibuprofen and naproxen. Fifth class is phenamates or anthranilic acid derivatives, in that mefenamic acid and meclofenamate are phenamates, so mefenamic acid and meclofenamate. Then aryl acetic acid derivatives, in that the examples will be diclofenac and tolmetin. In oxychem derivatives, pyroxychem and tenoxychem. And pyrrolopyrrole derivatives, the drug is ketorolac. This is the non-selective COX inhibitors. Second class is preferential COX-2 inhibitors, in that the drugs are nimesulide and meloxicam. Third is selective COX-2 inhibitors, in that the suffix will be coxib, celecoxib and rofecoxib. And fourth is analgesic antipyretic with poor anti-inflammatory action, in that there are paraimmunophenol derivatives, paracetamol and phenacetin. Now we will see at least one structure of each category. The first class is non-selective COX inhibitors, and in that the first category is salicylic acid derivative, and you know the structure of salicylic acid very well, which is benzene ring having carboxylic acidic group and hydroxyl group at ortho position, and the hydrogen of hydroxyl group is replaced by acetyl group and results in acetyl salicylic acid, which means aspirin. Easy? The second category is pyrazolone derivatives. Pyrazolone, not pyrazole. Pyrazole means 5-membered ring having 2 nitrogens. And here is pyrazolone, means pyrazole having zolona, O-N-E for oxygen. Oxygen connected by double bond to pyrazole ring is known as pyrazolone. And pyrazolone derivatives, in that we will do the structure of phenylbutazone. Phenylbutazone. On both the nitrogen, phenyl rings are attached, and butazone means C the side chain having 4 carbons, C4H9. That's why it is butazone. And ozone or butazone, O-N-E, means another extra oxygen is on the 5-membered ring. This will be the structure of phenylbutazone. Third structure is indole acetic acid. In indole structure, acetic acid CH3COOH is attached, and its derivative is indomethacin. In indomethacin, the methoxy group is on 6-membered ring, and chlorobenzene is attached to 5-membered ring. Next category is propionic acid, which means CH3CH2COOH. Propionic acid derivative, in that the examples are ibuprofen and naproxen, and we will do the structure of ibuprofen. So propionic, you can see the side chain in ibuprofen, that is CH3CH2COOH. That's why ibuprofen is in the category of propionic acid derivatives. Next category is phenamates or ethranolic acid derivatives, and in that these examples are mefenamic acid and meclofenamate. We will do the example of mefenamic acid, and before that we will see the structure of phenamic acid or ethranolic acid. Phenamic acid have 2 benzene rings attached with NH, and 1 benzene ring contains carboxylic acidic group. Or ethranolic acid means on benzene ring, amine and carboxylic acidic groups are attached on by ortho position. So this class are classified as phenamic acid derivatives also or ethranolic acid derivatives also. And in that the structure of the drug will be mefenamic acid. And mefenamic acid, further 2 methyl substitutions are on the benzene ring, and these substitutions are at the ortho positions. અને જેવી રીતે હું તમને ક્લાસમાં કરાવું છું એવી જ રીતે તમારે આ જે સેલિસિલિક એસિડ, પાયરાઝોલોન, ઇન્ડોલ એસિટિક એસિડ એ બધા સ્ટ્રક્ચર્સ મેં તમને અહીંયા સમજાવવા માટે આપેલા છે. તમારા આન્સર્સમાં ઓનલી ડ્રગ્સના એક્ઝામ્પલ્સના સ્ટ્રક્ચર્સ જ ઇન્ક્લુડ કરવાના છે, એન્ડ યુ નો દેટ વેરી વેલ, રાઈટ? Then the category is aryl acetic acid derivative, and in that the examples are diclofenac and tolmetin. Here we have included the structure of diclofenac. The class is aryl acetic acid. See, in the structure of diclofenac there is a benzene ring having acetic acid CH3COOH, which means aryl acetic acid derivative. Then in oxychem derivatives, pyroxychem is there. Then in pyrrolopyrrole derivatives, ketorolac is there. Then these are the structures of first class, non-selective COX inhibitors. Second class, preferential COX-2 inhibitors, in that nimesulide. Then selective COX-2 inhibitors, in that celecoxib. And the last class, analgesic and antipyretic with poor anti-inflammatory action, in that para-aminophenol derivatives. And in that the example is paracetamol and phenacetin. We have included the structure of paracetamol, which is para-aminophenol derivative. See, phenol means hydroxyl group of benzene ring, and NH, amino, both are at the para position. That's why they are para-aminophenol derivatives. And I am telling you once again, to remember these structures of the drugs, you have to practice it by writing again and again and again and again. After classification, we will continue with the mechanism of action. In previous lecture, we have seen this pathway of production of prostaglandins from the arachidonic acid, right? And here we will see only where the NSAIDs act. See, NSAIDs block the enzyme cyclooxygenase, right? So the cyclooxygenase enzymes are blocked, so PGG2 will not be produced. From that, H2 will not be produced, and from that, prostaglandins from auxin and prostaglandin I2 will not be produced. And if prostaglandins cannot be produced, then the inflammation is blocked. And it is very clear from the title that non-selective NSAIDs inhibit both COX1 and COX2. Preferential prefers COX2 over COX1, and selective COX2 inhibitors only inhibits COX2 isoform. As we know, COX1 enzymes are included in the process of production of prostaglandins, which are involved in the normal physiological function. And in these functions, the major function is the production of mucosal layer, which protects our GIT membrane. So, inhibition of COX1 inhibitors have side effects, that is gastric ulcer. And to reduce these side effects, selective COX2 inhibitors are used. COX1 enzymes produces prostaglandins, which are involved in the normal physiological function, and આ ફંક્શન્સમાં મેઇન ફંક્શન છે પ્રોડક્શન ઓફ મ્યુકોઝલ લેયર, જે એ લેયર છે આપણી જીઆઈટી મેમ્બ્રેનને પ્રોટેક્ટ કરે છે. If COX1 enzyme is blocked, then the prostaglandins will not be produced, અને prostaglandin produce નહીં થાય તો મ્યુકોસલ લેયરનું પ્રોડક્શન નહીં થાય. એનું પ્રોડક્શન નહીં થાય તો જીઆઈટી મેમ્બ્રેનમાં ડેમેજ થશે, which will result in gastric ulcer. એટલે જે નોન સિલેક્ટિવ કોક્સ ઇન્હિબિટર્સ છે એની મેઇન સાઇડ ઇફેક્ટ છે gastric ulcer, and to remove these side effects we clinically use COX2 inhibitors preferably. Then analgesic, this was the mechanism of action of inflammatory action of anti-inflammatory action of NSAIDs. Next is analgesic action. As we know, prostaglandins are the main responsible components for pain, inflammation. So prostaglandin causes pain by sensitizing pain receptors, and NSAIDs block their production, so the pain will be removed. But here we have to mark one thing: NSAIDs do not act centrally, but they act at the site of pain. So NSAIDs are useful in mild to moderate pain only. They are not used in severe pain because they do not block pain receptors centrally. While narcotics like morphine act on CNS, they block pain sensation centrally, so they are used in severe pain. That's why narcotics have more CNS side effects, and NSAIDs do not have more CNS side effects. Then we will see the antipyretic action of NSAIDs. Our body temperature is controlled by the hypothalamus part of our brain, and if pyrogens are metabolic products of bacteria and leukocytes. Pyrogen attack on hypothalamus, and then our body temperature regulatory process is disturbed, and this disturbance produces fever. Prostaglandin E1 is a potent pyrogen, which is fever-inducing pyrogen, and prostaglandin E2 causes pain, edema, fever, and reddening of the skin. So, to lower down our body temperature, we have to block this prostaglandin E1 and E2, and we know very well that NSAIDs block the synthesis and release of prostaglandins. So, the body temperature will be lower down, and it will be the antipyretic action of NSAIDs. Uses: because of their anti-inflammatory action, NSAIDs are used in rheumatic arthritis. Then, because of their analgesic action, they are used to relieve moderate pain such as arthralgia, which means joint pain, then myalgia, which means muscle pain, then neuralgia means no pain, toothache, headache, and dysmenorrhea means menstrual cramp. Then mild to moderate pain due to inflammation and tissue injury used in fever and as an antiplatelet agent to prevent thrombus formation in coronary arteries. Here see the thromboxane synthase gives thromboxane A2 and thromboxane B2, which are responsible for platelet aggregation. And platelet aggregation means thrombus formation. So cyclooxygenase enzyme is blocked, so this thromboxane cannot be produced. So the thrombus formation is inhibited. That's why NSAIDs are used as an antiplatelet agent. Adverse effects. We have seen the main adverse effect of the NSAIDs is gastric ulcer, which is of COX-1 inhibitors. Then in rare cases, salicilates produce allergic reactions such as skin rashes, urticaria, bronchial asthma, and anaphylactic shock. Urticaria means like itching, and anaphylactic shock is a severe form of allergy. Then fatty infiltration in liver and kidney, increase in bleeding time due to the disturbances in the production of thromboxane, nausea, vomiting, dyspepsia, and heartburn. Dyspepsia means indigestion, and heartburn means burning sensation in chest, mostly due to indigestion or acidity. So these are the adverse effects of NSAIDs. Okay. Thank you.